Welcome to the third installment of my How to Robot series. I'm Joe, and today we're going to be demystifying machine learning. I hope that you found the series helpful or at least entertaining. But now we're going to depart from programming tutorials, and we're going to start talking about more advanced things, and try to bridge the gap between the concept and the practical nuts and bolts of how you do it. And by the end of the episode, our little craft store robot will be operating with machine learning rather than hard-coded ifs and thens. You might notice this little guy lost an eye. Well, that happened in a fight with two other robots, and they were much bigger and heavier than him. So I think he came out okay. In order to make our little robot use machine learning, I first am going to have to simplify the controls of the wheels. I'm going to take the original code that controlled the I/O pins for the Arduino and group those lines into functions that will allow me to command the robot go forward, go backward, left, right, and so on. Then I will create a function called performAction. This function will have one input parameter, and that is an integer that will be the index of which action I want the robot to take. Then I will use a switch case statement to create 11 different variants of the basic actions this robot can perform, and I can call those by index. Now we have a very simple way for our machine learning to control the robot. We simply call performAction and give it a number that represents which action it should perform. With that out of the way, let's talk about machine learning. What we really need to do is get rid of this guy right here, the if statement. If statements are great, but they're hard-coded and they don't have the flexibility we need for our machine to learn real time. We need to create a structure that is flexible, and it can take any input and use it to affect any output. For this, we'll be using a table. That will be at the heart of the machine learning for this setup. Now, how does a table do learning? Well, let's start with the simplest possible table, a zero-dimensional table. It just has one cell. In that cell, we can place a number that is equivalent to an action that the robot will perform. But the robot will only perform that one action continuously. So let's give this table a dimension. We'll make it a one-dimensional table. And I've arbitrarily chosen 10 segments for the dimension, or what they call a granularity of 10. Now, if you have a sensor that outputs 0 through 9, that output from the sensor will select which one of those cells activates, and that activated cell will have an action that the robot will perform. Now, we can make a learning algorithm that will place the correct actions in the correct cells for each one of those sensor inputs. But there's more. We can add another sensor. How do you do that? You add another dimension. There is a dimension for each input to this table. Now we have a two-dimensional table with 100 cells. That is 100 places to put individual actions that the robot can perform. And depending on the value from each one of the sensors, it will select a single cell. You could think of the value from each sensor as being a coordinate, x and y. You could even add a third sensor, or condition of any type, and that will add a third dimension to this table. Now that's where this system of machine learning really starts to become problematic. As you add conditions, you add dimensions to this table, and your memory requirements grow exponentially. So what does that table look like for our robot? Well, we have two sensors, the left and the right bumpers, and they're binary, so they only have two states each. I'm going to use a three-dimensional table. One dimension will be the left bumper, which will have a granularity of 2, 1 and 0, and the right bumper, which is the same. The third dimension will be the last action that it performed. This will give it a memory of what it's done before by one action. Now in code, this is exceedingly simple. We make our table by creating a variable, and then we make it an array of 3 dimensions. Each dimension will have the proper granularity. With that in place, it's very easy to give the table control over the robot using the performAction function. We'll simply call performAction, and in the parameter, that is, which action that we should perform, we will give it that memory variable. And inside of those brackets that define the 3 dimensions, we will put in the last action performed, our left bumper, and our right bumper status. Now, how does the robot learn? Well, in the simplest form of machine learning, it's something like bad parenting. When the machine does something right, you kind of leave it alone. When it does something wrong, you say bad robot. And so we're going to add in our learning line of code. I'm going to declare a Boolean variable called bad robot. And whenever bad robot is true, the machine learning algorithm is going to randomly try some other action in that cell. This isn't an efficient learning process, but it's very simple. It'll get the job done in this case. There are much more advanced algorithms for figuring out how the value in the box should be modified, but they're kinda out of the depth of this video. Now, whenever the bad robot variable is true, it will simply try something else. The question is now, what sets the bad robot variable? And this brings us to two basic types of machine learning: supervised versus unsupervised. Supervised, as the name would suggest, requires human interaction. Most of the machine learning applications in the world that I know of use supervised learning. This means that there's a human that's telling it if it's done well or not. Typically how this is done is first, before an AI or neural net or any kind of machine learning is trained, it's given a data set. And that is a set of files, much like problems in a textbook in school. And the file has the data that the machine learning is supposed to process and the answers. So these people put these sets of data together and the machine learning trains on it, doing the problem, looking at the answer, finding out if it got it right or not, and changing itself if it got it wrong. Fun fact, you know those CAPTCHA I am not a robot things, where you'd select the squares that have, say, a bicycle in them or something like that? Well, those were actually using you, who are trying to log into a website, to add to that data set for machine vision. Very sly move. But getting back to the point, this robot will be unsupervised machine learning, which means that we need to build a teacher into it. We need to make some code that will say, bad robot, whenever the robot does something it shouldn't. Now, machine learning is very opportunistic. If it sees no negative impact of what it's doing, it will do it. The first thing we'll have to do is make sure that the robot actually moves forward. If we say bad robot whenever it hits something, the robot will simply sit still and go nowhere, and that solves its problem. We need to find quite a few reasons for it to keep learning and keep trying. I've boiled it down to a few, and it works. Rule number 1, if the robot spends more than 1¼ seconds doing something other than going forward, we'll say bad robot. Number 2, if the bumper that just got hit was also the last one to get hit, we'll say bad robot, so try not to hit the same bumper twice. Rule 3, if the robot goes forward and hits a bumper too soon, bad robot. And rule 4, if it's going forward and has hit nothing, if it does something else than go forward, bad robot. There's a few other things I've done in this program off camera, because they're just details, setting up timers, extra variables, keeping track of some stuff, clearing the bad robot flag. I do hope to post the code for this on my GitHub, but right now my GitHub's an absolute mess because I honestly never use it. But when I do, I'll put a link to it in the description in case you want to play with my code. Now it's time to put it on the floor and watch it run and learn. By the way, if you could take a moment to like the video if you found it informative or entertaining, and subscribe to my channel if you want to see more like it.